So in the last lesson, we learned about how to make ions. So the nonmetal atoms have a very high electronegativity. They're very strong. They steal electrons from the wimpy metals. And so what happens is they form what's called an ionic compound. And an ionic compound is a substance made from two or more kinds of ions bonded together. So these are generally, they are made by cations. Remember, cations are positive. Being strongly attracted to anions, which are negative. Remember, opposites attract by Coulomb's law, and they are in some fixed ratio. Not ration, ratio. So the anions and cations bond in a fixed ratio. So here's an example. If we have magnesium, which has a +2 charge, and two chlorine ions, each with a -1 charge, it produces magnesium chloride with 0 charge. Right? You don't want to have charges floating around. You can't just have a positive without having a corresponding negative. But in this case, we see that magnesium, which has a low electronegativity, gives up its valence electrons, 1 to each of the chlorines. Now, when that happens, magnesium has lost 2 valence electrons. It becomes magnesium +2. So it has the electron configuration of neon. It has the electrons of neon, so it's good. Each chlorine gains 1 electron, so it has the electrons of argon, so that's good. If both of them follow the octet rule. And now, because magnesium has a 2+ charge, it's strongly attracted to the negative chlorine ions, so they stick together. It's like a process. The first process is the chlorine steals the electron from the wimpy magnesium, and once it's stolen that electron, it's negative, and the magnesium is left positive. Then they stick together. So, ionic compounds. Metal and nonmetal elements combine to form the ionic compounds. And generally speaking, the electron arrangements of the cations and anions resemble the arrangements of a noble gas atom. So this is what we call the octet rule. If you need to pause here, I'm going to move forward, but you can pause if you need to if you haven't finished copying down. So the rule of 0 charge. In an ionic compound, the positive charges on the cations and the negative charges on the anions must sum up to 0. There can't be a net charge on an ionic compound. So for example, if I have Mg, which is 2+, and 1 Cl-, this doesn't work because I would be left with a leftover charge of +1. Instead, what I get is Mg, which is 2+, and then 2 Cl-, which we write as MgCl2. So MgCl would not work. Whoops. MgCl would not work. You do not need to copy this down. These are just some examples. Things I want to point out is we have NaF, in sodium, 1 valence electron, fluorine 7. So if we have a total of 8 valence electrons between the two, we're good, we're all set. So this would be NaF. But now if we have, let's move down to potassium selenide, down here, K2Se. Each K has 1 valence electron, Se has 6. So Se needs 2 E minuses. Well, 1 potassium isn't enough. So what we have to have is 2 potassiums to balance it out. So what we see here is total positive charge. We have 2 times the plus 1 evens it out. So all of these you'll see equal out to 0, except this last one. That should be a 3 right here. That's a mistake. All right. And that's about as complicated as it gets. This last one where aluminum has 3 valence electrons, oxygen has 6. So in order to have this even out, well, we need to have 2 aluminums and 3 oxygens. Each oxygen takes 2 of the valence electrons from aluminum. So octet rule revisited. The number of electrons associated with the atoms of an ionic compound generally totals 8 or a multiple of 8. I don't like using this, though. I want it to be more something that you understand. You can figure out the charge of an ion by looking at the periodic table, and then you balance out the charges that way, and it tells you your chemical formula. So wrap up. How can valence electrons be used to predict chemical formulas? Well, metal atoms and nonmetal atoms combine to form ionic compounds. In those ionic compounds, the metal is considered a cation, nonmetal is an anion. This is a review. The key idea today, the charges on the cations and anions in a compound, ionic compound, must sum to be 0. And they do this by making ratios that result in that 8 valence electrons, multiple of 8 valence electrons. But really they do it in a ratio such that the charge is equal to 0. That's the way I would think about it.